Eagles 9, patch 3.
All right, thank you. Everyone hear that? Eagles 9, New England Patriots 3. What are the odds makers in Las Vegas saying on this? Anybody know? Okay.
Listen to Doug.
So my name is Doug Stumberger. I'm currently a technical architect at Forum One. I've been developing on the Drupal platform for 11 years. Most of that time I've been a freelance/contract developer and technical architect. And then a few months ago I joined Forum One full-time as a technical architect. Forum One is an award-winning digital agency for nonprofits, foundations, and government. And it is an awesome company. It's based in Alexandria, Virginia. We have an office of about 20 people in Seattle, in downtown Seattle, with a spectacular view of the Olympic Mountains. We are hiring, as I imagine most Drupal-based firms, although we also do WordPress and a bunch of sort of front-end development and visualization. You can find out more about the company at forum1.com. /careers is our jobs page. And please feel free to contact me at dstumberger@forum1.com. So my talk today is about software estimation. And I would say that I picked this topic to talk about today largely because it's one that I'm interested in and one I didn't know a huge amount before I started this presentation, before I started this. And so I really wanted to learn more about it. Okay, let's see if I can figure out how to make this go forward. And I'll say straight off the bat that much of what I'm going to present today I learned from this book, which is, I would say, probably the most, from what I can tell, the most widely read book on the topic. This is Software Estimation by Steve McConnell. The subtitle is Demystifying the Black Art. And to some degree, I think software estimation is a bit of a black art. Here's the teaser for my talk. It's hard. It's actually harder than you think, I think, to create good estimates. And I want to talk a little bit about what's the point of doing any estimation at all. Is it to figure out how much to charge a client? Is it to figure out how late you're going to be? What is the point? I've got 10 rules of estimation, 4 techniques for estimating, and some thoughts on estimating calendar time and cost. And a couple things that I promise in this talk. 1, there will be a history quiz on English history. And 2, I will have at least 1 mention of Bitcoin. Okay, so Steve McConnell calls software estimation a black art. What is a black art? Well, I looked it up. It's an interesting sentence. A black art is a technique or practice considered mysterious and sinister. So, of course, I have the black cat here. And I don't know about sinister, but I know a lot of people consider software estimation mysterious. And that's because most estimates are really just guesses that people do. And most of the estimates that people come up with are wrong. And I will tell you that most of the estimates I've ever done are simple guesses, and most of the estimates I've ever done were wrong. And usually, as I'll talk about in a second, they're wrong by a fair amount, like 100%. And if you have an estimate that's off by 100%, you're probably doing pretty good. If you have an estimate that's off by 400%,
now we're talking.
Yeah, that's probably more like the industry average. So I've been doing estimation on the Drupal platform for 10 years now. Clients will say, "Oh, I'd like to add multilingual to my site. How long is that going to take?" And I'll say, yeah, I would say 22 and a half hours. And how did I come up with that number? I put my finger in the air, I felt for the wind flowing around, and I said, I think I can do it in that amount of time. I I had a project like this a couple years ago. I think it took about, I don't know, 2 weeks, and I wasn't working full time, so I'll come up with a number. So I would say largely it's thought of as a black art because we guess a lot, and most of the guesses are wrong, and we can find much better ways to do estimation. How good are we at estimation? So this is straight from Steve McConnell. 50% of projects. Now this is these stats are largely looking at projects that occurred in the pre-Drupal era, but I think most of us would agree that this is probably pretty accurate. 50% of projects come in late or over budget. I think it's probably higher, but 25% are canceled outright just because they run so long that they are perceived to be a failed project and aren't completed. And 25% are delivered on time. Yes, question.
And wasn't there also a kind of a rule of thumb, this is going back 20 years ago, as soon as a project hit $1 million, the chance of it being canceled was better than, or failing outright was better than 50%?
I have not heard that rule. The question is, wasn't there a rule that if when a project hits $1 million in probably expended cash or that expended cost, that it's probably
better than 50% chance?
Yeah, more likely than not to be a
complete
complete
failure.
failure. I think that's correct.
Yeah.
And certainly the larger, so the other related law is the diseconomies of scale of software, which is the larger a project gets, the more expensive it gets in a sort of exponential fashion. Okay, so starting to look a little bit about estimation and sort of the quality of estimations. What we find is that there's this concept that is all through the literature on estimation, which is called the cone of uncertainty. And I picked this image on the left because it really is the case that when a project is at the very initial stages of discovery, of estimation, before it's really clear on what you're building, on what technologies you're using, what your external data integration points are, what your database schema is, when you're way at the left edge of this cone, which is a cone that is the uncertainty cone, that your estimations are kind of by definition going to be likely to be highly variable. Let's put it that way. I won't say wrong, but highly variable. And in fact, McConnell talks about estimations as being at the left edge of the cone of uncertainty, of being approximately, or being off, or at least there is a variation in the quality of the estimations of about 4 times on the negative side, and 1/4 times, or 0.25x on the more favorable side. In other words, if your estimate is 2 weeks, it's probably just as likely to end up being 8 weeks or 1/4 of 2 weeks, and half a week. As decisions are made and time progresses, and those decisions are design, wireframing, selection of modules that you're going to use, and let's say selection of libraries, and all the way down at the very end of the cone, the actual implemented code, your ability to estimate becomes much more accurate. And so it's sort of you start on the left edge, not knowing very much about your project, and not being able to estimate very accurately. And you end up knowing a lot about your project because you've got a body of code that you've just written, and of course you can estimate spot on at that point. So
I'm sorry.
Yeah.
That doesn't drive with reality that I just saw right there.
Okay, tell me.
Do you find that drives with reality? I know that's a guy who wrote a book, but Steve, I've heard about that book, but I mean, we're a couple years into a project I just came on to, and we still don't estimate at all. It's pretty bad still.
Uh-huh.
Yeah, I've been on a lot of different agile teams, and it's not really like the chances we complete an iteration successfully, completing everything we've estimated, is probably 25%, maybe. Maybe.
Well-
I'm just saying, do you find that once, is that reality for anybody else? Like,
So the question is, do I find this to be a good representation of the reality where early on in a project, and I would say even in an individual sprint or a set of sprints, early on in a project or in the development of a feature, before you've made a lot of decisions that pin down design, development tools, and what the sort of inventory of development is, the manifest, that it's very hard to create good estimates. And I would say that at a high level, the concept of the cone of uncertainty does, I find it,
that part
it does match, yeah.
100%,
Yeah. And I do have a part of the talk about estimating in agile projects.
Oh,
So.
okay, maybe this.
Yes.
I feel like there's a line here where, like, that when you hit 1x, that's the point when you deliver the feature.
Yes. Yeah, no, yeah, I think that's right, and I tried to make that clear before. Yeah, the rightmost point of the cone of uncertainty is you've just released the code to production, and if someone at that point said, "Well, how long is it going to take to build this project?" you would just basically look at your phone and say, "Well, I started this on this date, and I've just and I look at my time tracker." Which is going to be one of my best practices here, and my time management system says I spent exactly 242 hours on this. Well, I know what this is going to take. So that's kind of the point, is that when you get to the point where there are no more decisions to be made, you have an extremely good, obviously, perfect sense of the ability to estimate what it's going to take to build that, or what it took to build that. So what is the point of estimation? And you sort of think, well, I'm going to predict how much effort, or what size a particular feature, or an agile story, or a bug, or a system, or a website is going to take. But the point of the estimation process is not specifically to guess or estimate how long it's going to take. The point is to allow the control of a project, the management of the project, to successfully complete that project. So the goal is not, I think it's going to take this amount of time. The real goal is to provide sufficiently accurate estimates so that a project can be controlled to successful completion. And the levers of control are staffing level, calendar time, budget. Right? And those are sort of all related. So the idea is you want to be able to create an estimate that a project manager, and you may be the project manager, or you may have a team of project managers, the project manager can use your estimates in order to figure out how to get to the end zone. I think today is the day I can certainly use an analogy, football analogy. So how do I get to the end zone? Well, I get to the end zone by having pretty good estimates. In fact, if your estimates are off by some amount, and let's say they're consistently off by 200%, it's highly unlikely that any project manager can get that project to successful completion, because they just are unable to ascertain how to tweak the project plan in order to make it to a completed state. In addition, estimation really enables us to improve the quality of a delivered project. If you underestimate, and this is exactly what happens for me a lot of the time, I underestimate a feature or a sprint, and my project manager says, "That's great, but you still have to complete what you said you were going to complete, what you estimated you were going to complete in the time given." And basically what that means is I code faster and my technical debt goes up. So the better we are at estimators, the lower the technical debt by the time we get to the end of the project. Technical debt is the junk we put in code, the poor coding practices that get baked into a project. And I would say the longer we spend working on code, I mean, obviously there's a point of diminishing returns, But if you've given yourself and your team enough time to build software with high quality, and you do that by estimating that from the get-go, you're more likely to deliver a product that has high quality. And basically, the goal is to improve product delivery, reliability, and ultimately profitability. I mean, I know not everyone in the audience here is building websites as part of their business. Some people are on the client side, some people are on the design side. But the fact is that we want to deliver a profitable project if you're building, and one way to deliver a profitable project, even if it's your own project for a non-monetary goal, is to be able to know when it's going to be done, how long it's going to take, and what it's going to cost. Okay, so my 10 rules. I've got 3 slides. Rule number 1 is on one slide. Rule number 2 is on another, and then I've got all the rest on the 3rd slide. So rule number 1, create an estimate, not a target. So an estimate says this feature, story, bug, project, website is going to take this number of hours, and I may decide to calculate that number of hours based on the size of it, the estimated size of it. And that estimated size, as I'll talk about, could be a matrix of numbers having to do with the number of modules involved, the number of languages used, both natural languages in a multilingual site or coding languages, the number of front-end libraries. So basically what we're doing is looking at how much effort a project or feature is going to require, and it's basically not, an estimate is not, well, I have to finish this project by March 3rd. That's not an estimate. So basically what you want to do is when you're estimating, you want to put aside the budget and schedule that your project manager or yourself are looking at and look purely at the functionality that is being developed and figure out what it's going to take. Your goal as an estimator is not to figure out how to get that done given the budget, the team strength, and the schedule that you have in front of you. It's purely to figure out what it's going to take in terms of effort and time to get there. Rule number 2, don't underestimate. So basically, from what I've read, beyond just Steve McConnell, almost every estimate that is given is an underestimate of the amount of effort required to build software. So many estimates are off by 100%. Most estimates are off by 100%. Often more, especially at the left edge of the cone of uncertainty. Now, my second point here is don't worry about Parkinson's law. So Parkinson's law says that work expands to fill the time available for its completion. So there's this thing that managers, McConnell talks quite a bit about managers who will say, I'm worried about my team, giving my team too much time to complete a task. So don't overestimate how long it's going to take, because I don't want my team taking 2 weeks to do a task that really could have been done in 6 work days. Well, basically, don't worry about Parkinson's law, because it's highly unlikely that you are going to underestimate how long it's going to take to do something. Developers will often want to display their proficiency and expertise by underestimating how long it's going to take. Oh, I can do that. And I've fallen into this trap many times. I can do that. It's only going to take me 4 hours because I know how to make multilingual sites work in Drupal. I know that. Well, that kind of optimism is great, but it does not translate into accurate estimates. Don't let your manager or client create urgency. Low estimates lead to low quality, technical debt, and client unhappiness. And that's something that no one wants. Oftentimes, when you underestimate, you get into a situation where someone is basically saying, you're behind, code faster. And as we just talked about, that just leads to technical debt and poor quality. Schedule slip has an unlimited downside. So basically, if you say it's going to take 2 weeks to do, 2 weeks of effort, and you've underestimated, your schedule slip on the underestimation side has no limit. So you said it's going to take 2 weeks of effort. It could easily take let's say maybe not a year, but the amount it could take above that is kind of unlimited. It's better to overestimate, basically under-promise, over-deliver. Okay, rules 3 through 10, I put them all on one page. Don't expect to be good at estimation at first. Don't be too precise. So coming out of a meeting and saying, yeah, that estimate, I think the feature's going to take 4.39 hours. Well, that's really not all that useful information, the 0.39. To say it's going to take 4 hours, or even to say it's exactly a number of hours, is probably more precise than you need to be. Yeah, question in the back.
May I just answer it? But the question I go back and forth with is it better to say, all right, I'm thinking this is going to be 10 to 20 hours, or this is going to be 15 to 20 hours, or this is going to be 20 hours? What's the better way to set up client expectations?
Well, good. So I think the question is, what's the way to set up client expectations for a range?
Is a range the appropriate thing, or is it better to just overestimate and then always underdeliver?
Yeah. So and I'm going to answer that question, and the answer is it's better to give a range.
Okay.
And within that range, you can actually use a little bit of math, it's not hard, to come up with an expected case.
Okay.
Right? It's not a most optimal case, because you're going to define a best case and a worst case. And then you're going to pick a point in between that range.
So 3 points.
Yeah. Actually, you're going to start with 4, and I'll talk about that in a minute.
I see when you have a tendency to give a range, it's also like there's a matter of lack of definition for the feature, where you might need to figure out what you're going to build first, or a level of risk, where it's the kind of thing where it's like, we might build this custom solution at first pass, it may require iteration, or it may require additional testing.
Yes. So if I can characterize that, I think the question is, should you use should you characterize estimates with a risk level?
Yeah.
And I would say yes, maybe, but a range is probably an efficient way, and maybe a more efficient way than identifying what that risk is. So to identify, and I'll talk about this in a couple of slides, to identify a worst case is really to say, I think it's going to be this, but there's a risk of 200% additional cost. So that is one way to absorb risk into an estimate. Don't provide a confidence level unless you have the numbers to do so. And I'll talk a lot about counting and numbers. Don't rely on your intuition, even if you are an expert. And really the rule here is, if someone asks you for an estimate, don't give an estimate right off the cuff. I've been in so many meetings with project managers where they say, well, how long is that going to take? And I have said many times, it's going to take 6 hours. It's going to take 2 points, 2 story points. So one of Steve McConnell's top recommendations is, do not do that. Walk away from that meeting, sit at your desk, and for 15 minutes think about the project or the feature that you're developing. And write down the 3 things, whatever that number is, that you know you're going to have to do, and come up with a considered estimate instead of shooting from the hip. Do provide estimates in a range from best case to worst case. Do collect your organization's data and use it to improve your estimates. And I'll talk about these. Do use the law of large numbers to your advantage. I'll talk about that some more. And remember the diseconomies of scale for software, which just means the bigger the project, the more it's going to cost, and it's non-linear.
Real quick.
Yes.
Those 2 key buzzword things.
Yes.
Law of large numbers and diseconomies of scale. Is that covered in the book?
It is.
Okay. This is
Yes.
all like the summary of the book?
I think everything I present here is in this book in one way or another.
Thanks.
Except the English history. That's my own. And I will say, I do a lot of cooking. I don't do a lot of baking. So I do a lot of cooking because I love to improvise based on the flavor of things. I don't do a lot of baking because I'm not great at following recipes step by step. So everything you've read here is my take on what Steve is talking about. But I doubt he would complain too loudly about what I'm presenting if he were sitting in the office, in the audience. Yes.
So I wanted to add something. Also, do not estimate if the request is ambiguous and unclear, because that's when you actually get in trouble. You think you understand it, but I think bombarding them with questions to make sure that you have the most detail that gets you to a more accurate estimate.
Yes, so excellent rule. Find out what you're estimating. Have the client tell you what you're estimating before you come up with a number. Yes?
And the corollary to all that is you have to have some cojones, because sometimes they're going to say, oh, come on, just give me something rough. I just need something rough.
Exactly.
How many times have I heard that?
Yeah, just give me a rough.
Right, just give me
Yeah,
something rough.
I need something simple. Yeah,
Yeah.
just any number. Just give me. That's right. And that's actually one of, I think, the best points of this is don't shoot from the hip.
Yeah.
And there are specific techniques that do not take very long to come up with a more considered and better estimate than just coming up with something out of your judgment or intuition as an expert. Because to some degree, you are probably an expert in Drupal in one form or another, and that's kind of why you're, or maybe you're an expert in, in developing your website for your own personal use, but using that expertise is still fraught with peril if what you're doing is making intuitive, judgment-based estimates and not using a couple of fairly straightforward techniques to quantify more accurately how long it's going to take to do something. All right. Okay, so I'm going to do 4 estimation techniques, and I would say this book probably talks about triple that number. And in fact, I'm specifically not going to spend any time on the sophisticated model-based techniques like Kokomo 2. And if you go to work at NASA, you probably end up, feeding into some very sophisticated numerical models like Monte Carlo-based simulations to figure out how long a project is going to take to build the software for the booster phase of the next heavy lift transport. So not going to work on that. The sort of sophisticated model. Going to spend time looking at expert judgment with decomposition and ranges, and that's what most of us do most of the time. We're going to be looking at group-based expert judgment, and particularly with Scrum Poker. We'll talk about Wideband Delphi, which is kind of the most common group-based expert judgment. And then a method that I would call, and he doesn't call this exactly, is count, calibrate, and compute, which I think is the best way to come up with estimates. And then t-shirt sizing for high-level comparisons of effort to value. Okay, so Steve says, the worst estimates occur when experts use only their judgment. And then I've added a few things here, especially when they give off-the-cuff estimates. Or use only their intuition. It kind of says that with only their judgment. Or rely on their memory of how long a similar task took the previous time. And this last one is quite interesting because it turns out that most people, when they think about a project they did last year or 2 years ago, they don't remember exactly how long it took to build a feature. They remember what their estimate was. And if their estimate was off by 400%, then the new estimate's going to be off by 400%. So you really want to have a data point that, I look back 2 years ago, and for me, I have, before I joined Forum One, like I said, I was freelancing. I have 10 years of Excel spreadsheet that lists the amount of time I spent down to every 15 minutes on every single task that I've been asked to work on, and every project. So that's my way of being able to say, oh yeah, I can look back now on this project and say, well, to do that particular feature took me exactly this number of hours. All done in Excel, fairly stupid, I mean, there's nothing sophisticated. I don't even use charts in there. It's just straight line after line. So it could be easier to navigate, but I have that data.
I feel like I should be asking you to share that spreadsheet. I know it's your programming.
Yeah. No, it's really
mine,
simple.
but
It
still
says
would be amazing.
it says the date. Right. The value is actually the historical record. Okay. Expert judgment with decomposition. Very simple. So ignore that first line. I don't know what I meant to say there. So the idea is to take a task, any task that you're asked to estimate, to decompose the project in component pieces that are approximately less than 2 days of effort apiece. And I'll talk about something called a work breakdown structure, which is a more formal concept for this. You want to decide which disciplines will be included in your estimate. That could be user interaction, it could be design, it could be test, it could be documentation. And you want to estimate the level of effort for each component of each discipline. So basically, you're taking your task, you're writing down what are the steps, what are the results, what are the moving pieces of this, what are the gears in this particular widget that I'm estimating, and what are the disciplines. Do I need to do testing? Do I need to do deployment? Do I need to do documentation? And I'm going to add those up, and I'm going to come up with an estimation. Very simple. So this concept of decomposing, there's a sort of more formal concept called the work breakdown structure. And again, when you go work for NASA, you will probably be building some very sophisticated tree-based work breakdown structures. But really, I think this is write down what's in the feature, what's in the particular story. I did this last week again, this is a translation-oriented project where we're adding translation to an existing Angular application. And I sat down with another developer, and we just whiteboarded, here are the 15 things that have to happen, starting from, deploy this particular Angular 1 library, all the way down to press the button to do the code integration on Git and the deployment to production. So we came up with those 15 things, and we did our work breakdown, and we associated a number in hours with each one of those, and we added that up. So to be sure to include in your expert estimate all technical elements of the solution. So are you building modules? Are you deploying contributed modules? Are you building views? Are you making configuration changes? Now, some things like a configuration change will happen automatically when you build a new view and save it. So you're getting configuration added into your repo. But sometimes, like on Migrate, with Migrate module in Drupal 8, you are building configuration files as an artifact of the work you're doing. So you want to basically create a manifest of the items that are being created and deployed for your solution. You also want to make sure you include the cost of context switching and project overhead. So for me, I add in my mind, if I'm asked to do an estimate, I usually add in 30 minutes just to find out what I'm supposed to be working on. Because I was working on something completely different on a different project for a different client up until 11 o'clock. And then I'm supposed to work on this new feature on a different project for a different client from 11 to whenever. It's going to take me a little bit of time to go to the bathroom, get a cup of coffee. Oh, and now I have to figure out where is that ticket and what do they really want there. So there's this context switching that's a bit of an overhead. There's also the environment switching cost. It takes me a while to get Vagrant up and running. I may have to pull down a copy of the database and install that. Also, you want to think about unit testing, all flavors of testing, and all flavors of code management, source code management and deployment, and documentation. So coming up with a number for a feature or a story is not so easy and not so hard. It's not so easy in that it's easy that you can just say it's going to take this amount, but it's not so easy to come up with an accurate number, but it's not that hard either. You come up with a manifest of what you're going to create. You come up with a work breakdown structure, which can be a simple list of the results that you're trying to accomplish, and you associate costs, estimated costs, with those numbers. You add up those estimates, and you get your rolled up software estimate. Yes?
The worst part is when the project manager just says, oh, that's just a configuration change, right? So like 5 minutes. And they're not
Yes.
thinking of like, okay, that's on dev. How you gotta go through testing and staging and get to production. Like they're not thinking of everything it takes. And
That is
always a fight to
yes.
get them to understand.
I won't estimate any task, even if it's a one character change in a file, at less than 1 hour, because it takes me that long to create a new feature branch. Pull down all the current feature branches, create a new feature branch, merge that feature branch after I do my changes, push that feature branch up to development, review it on development, create a pull request in Git to move it from development to staging, and then, if I'm doing the production deployment, then do a production deployment, which involves creating a backup copy of the database, alerting sysadmins, the whole business. So really, and I think 1 hour is maybe optimistic. It may be more like a 2-hour overhead for any change to a software system that's going to end up on a production server. Yes?
There's got to be a metaphor that we can use to tell that to people, to explain to people. Saying you saying that this is going to take only 5 minutes is like saying a doctor is only going to take 20 minutes to cut out an appendix. You're forgetting all the parts and something that's going to really allow them to get it. I don't have the metaphor, but does anyone?
I have a non-metaphor.
All right, so the question is, can we come up with a metaphor to explain that there's a certain amount of machinery and time involved just in deploying a simple change, making a simple change and deploying that through to a finished
And
system?
It's harder too if project managers or your boss have come from the school of, well, you just go to production and make a change, right? It's like,
Yes,
I know it literally only takes 5 minutes, right? Or you can.
that's right. Yes.
I'll take the result we're
Right.
To answer your question about the metaphor, it's not exactly a metaphor, but more a story that I read once. It's always stuck to me. And the story was like this. This giant factory was having problems with their systems, and they called in this expert to come in. He came in one day, walked through the factory, looked at things, and then went up and put an X at a certain spot, and then said, change that, and it worked. And then sent them an invoice for like $10,000. And then he got an email back from the owner of this is a made up story, but gets an email back from the owner and says, $10,000 for drawing an X on the machine? That's quite a lot of money. Could you explain or justify yourself? So then he sends back a revised invoice that says, marking X on the machine $1, knowing which machine and where to mark the X. Later. And that always stood out to me, and I've told clients that story.
Or it may be like batteries not included. If you want the
Yeah.
batteries included, you need to include that in your
Batteries not included, yes. So I think we as a group should think about the right analogy for that while I move forward, because I'm running 7 minutes behind on my presentation. I estimated the number of slides, and I clearly underestimated the amount of time I would take to do this.
You
Okay,
didn't factor in questions.
that's right. So we just talked about a way for an individual expert to come up with a better estimate. Use a work breakdown structure, figure out what's going to be built, and what components of that, what sort of services, documentation, tests need to be included. But a better way to build estimates is to use a group. And I'm going to talk about two group-based approaches. One is called Wideband Delphi, and the other is called Scrum Poker. So Wideband Delphi is a method that's been explored a lot. It came out of, this is a variation of a method that came out of the Rand Corporation in the 70s. Basically, it's a structured group method, and it's by structured group method means you get some people, usually let's say 4 to 6 estimators in a room, and it's structured in such a way to prevent the most assertive estimator in the room from dominating the conversation and dominating the estimate. So McConnell suggests that wideband Delphi can cut estimation error from 290% to 170%. So of course you read that and you think, whoa, great. So now my estimates are only 2 times wrong, not 3 times wrong, 4 times wrong. But it is the case that even that amount of improvement in your estimation is a significant win. The method is best done in person, but can also be done even through through chat or email. The best results for any of these group estimation tasks is to use people with a mix of expertise. This is particularly good for projects in the early stage of definition on the leftish edge of the side of the cone of uncertainty, especially for projects that use new technologies. And I'll talk about what this project is. You can't really see the background. It's a form, and I'll talk about that in a second. So to do wideband Delphi, you get people in a room, you nominate a coordinator, and you find what's called an estimation form, which basically is a form that says, here's a feature, and here is what I think it's going to cost. And the estimators, let's say there's 4 or 6 of them, could be smaller, could be more, but probably you don't want too many, prepare and submit initial estimates separately. And they give those estimates to the coordinator anonymously. That's the key thing. So each person is estimating separately. They give the estimates to the coordinators. The estimates are anonymous. The coordinator summarizes the estimates, comes up with an average. The estimator shares all of the estimates. The coordinator shares all of the estimates with the people in the room. Then there is discussion. Hey, wow, one of these estimates was for 10 weeks. Everything else was for 7. Why do you think that could be 10 weeks? And the estimators then vote anonymously on the average estimate, and only when everyone is in unanimous agreement is an estimate approved. So this process can lead to a 40% improvement in the estimate accuracy compared to what the initial estimates were given. All right, so what if we use Scrum, Agile, or Extreme Programming, or Crystal, or any of the 40 million variants of Scrum? Do we still need to estimate? Well, yes. So even if you're iteratively fitting a set of work to a fixed period of time, and you're doing that iteration over and over again, and you're changing exactly what goes into an iteration based on the client priorities at that time, you still need to estimate to figure out how much work you can accomplish in a sprint. Pretty straightforward. And the way that typically is done is to use relative estimation values and to do and this is a technique for doing Scrum estimation. It's called Scrum Planning Poker. Very similar to wideband Delphi. So you can see in the picture on the left, there's a bunch of cards. Those cards have numbers on them, 0, 1/2, 1, 2, 3, 5, 8. It's the start of the Fibonacci sequence with some other big numbers attached, 13, 20, 40, 100. So the way Scrum planning works is you get a small team together, and you do this, let's say, a day or two before your sprint's going to occur, and you present a set of stories, features, and bugs. The group picks the easiest story, and they assign some low value to it. Let's say 2. So we say this story, which is very simple, it's a 1-line change that's going to take probably 2 hours. We'll just say that is a story point of 2. And then for all of the rest of the features that are being estimated, you come up with a relative complexity value above that baseline story. So, oh God, this other story, which is adding filtering, adding Solar search to this page. I'm gonna add a search bar to this page, a search form to this page. Yeah, that's more complex than that configuration change. I would say if the configuration change was 2 points, this is probably 8 points. So you come up with relative values, and then the point is that each person takes a card from their deck, and you can buy these decks on Amazon. They're $10 a piece. Puts the card down, face down. Again, we want some sense of an anonymity to the estimation so that there's no single person who dominates the process. All the cards are turned over at the same time. Then the group discusses the estimates that are shown and reaches some type of consensus.
There's an online version too.
Thank you. There's online versions. There are apps. There's a plugin for Jira. There's lots of different ways to.
You can use your palm.
What's that?
Use your palm.
Use your palm, yeah. And they have cards for taking a coffee break, and that's my favorite one since I'm basically addicted to coffee. So instead of story points, you can also use, and this is one of the sprinty, scrummy things. You can use anything as a relative measure. So gummy bears are very commonly used to measure and estimate sprint items. But the point is that story points, gummy bears, jelly beans, donuts, whatever you want to use, they're relative units of work. And they need to be calibrated to the velocity of the team based on historical data. And the way you do that is you develop your estimates before a sprint begins. You finish the sprint, and therefore you can calculate the exact velocity or the amount of work that was accomplished by this number of people in that number of hours in this sprint time frame. And then using that data, you can estimate future sprint efforts based on that. And you then repeat and recalibrate as sprints move forward. So the goal is you do your estimation first, your very first estimation, your first sprint, or whenever, and you're basically calibrating what you've been able to accomplish based on what you estimated. Okay, we're going to talk about count, calibrate, compute, and here comes my English history quiz. And can anyone identify this figure from the Bayeux Tapestry? That'll give you a hint. And I'll just say he was a king of England.
Oh, was it? Oh, okay.
And he was a fabulous counter, not himself personally, but
And a sharp wrestler.
he was kind of. I know. I love the outfit. Somehow that doesn't strike me as regal or kingly or majestic, but there you go. Okay, so that is William the Conqueror, who 20 years into his reign as the king of not only the king of England, but also obviously the Duke of Normandy, he decided that he wanted to know how much tax he was going to raise next year and how many feudal service days he was going to get out of his nobility. A feudal service day is, basically a knight delivered to a battle, more or less. So he created a group to go out and count basically every village, every person, every cow, every farming implement in England at the time. And that book was compiled, and it's called Domesday or Doomsday. And that was in 1086, and I think it was the high point of census taking for the first 2,000 years, for the last 2,000 years, except until maybe the U.S. census started really picking up steam. But I think it's kind of a brilliant example here because he didn't want to estimate. He wanted to, he thought the best way for me to estimate how much tax I'm going to make next year is actually to go ahead and count what I need to know to figure that out. It's still an estimation because it'll say, well, yeah, there are this many people, this many towns, I think I'm going to get this amount of tax. But that counting is super, super important for estimation. So as estimators, we're going to do a method called count, calibrate, compute. So what are we counting? Well, ultimately, Steve McConnell says you want to count lines of code. Lines of code is kind of a difficult thing to count. There are.
Was he at Microsoft?
I don't know. It's Microsoft Press.
Okay.
Or you could count source lines of code or 1,000 lines of code. But actually, I think more interesting is to count any number of things. Now, what we're doing here is we are calculating an estimate and what we're going to calculate is the size of the feature, project, story, whatever. And we're going to calculate that size in any number of things that can be counted. Content types, field, display modes, modules. I just listed as many things as I could think of. And then what we're going to do is we're going to calibrate that to historical data. So remember my spreadsheet of Excel where I said, I've got that whole spreadsheet and I can look back and say, with some sense of, accuracy, for me to deploy on Drupal 7 this type of feature, a view, to build a view, chuck it into a feature, roll that feature up. Yeah, that took, 3 hours and 4 hours. And if my current feature that I'm estimating is, oh goodness, here's the 10-minute, if the current feature that I'm estimating is 4 views, well, I now can calibrate and calculate based on my calibration of how long it took me to build a view in the past. So things that you want to use to calibrate is obviously the time you spent on development, and that can be a recorded or calculated estimate. And I'll show you an calculated estimate in a minute. Some measure of the lines of code or over unit of time. You could even do git commits per developer per day. It's not hard to figure that out, and I'll show you that in a second. And you also want to keep track of if you're really spot on, the percent error of your previous estimates for projects and features of a similar size or functionality. Remember, if you think back on something you did 2 years ago, you are more likely to remember what you thought it was going to take than what it actually took. All right, so here's the feedback loop for estimation. You're going to create a product requirement. You have a product requirement. You need an estimate. Well, in a previous process, you're going to have created an epic. You're going to have some stories. In that, I'm using agile terminology here, but it's basically features. You're going to create code that's some type of manifest. You're going to have entities, display modes, views, theming templates, libraries, modules, you name it. And you're going to have a recorded value for the amount of effort it took to accomplish that manifest and to complete the story. And by keeping track of that information, you can then use that to calibrate a very accurate estimate of what your current task is going to take. Okay, so what tools should you use for ticket tracking, sprint planning, time tracking, and estimation? Yeah, so there are just dozens of tools. So at 4-on-1, we use Confluence, we use Jira, we use Toggle, we use OpenAir, and we're integrating all of those so that we can provide rolled up costs meaning the amount of time it took to develop, all the way up to the product requirement level, so that a business development person can say, this client needs a multi-language site that supports 3 languages. They can look at a historical snapshot of what it took to build that for 2 other clients. That's the goal that we have. Okay, the goal of software estimation is not pinpoint accuracy, but estimates that are accurate enough to support effective project control. I could stop the presentation right there, but I have a few more slides to do. And this, I love this. So this is t-shirt size. I wish I had invented this because it's so simple. So this is what Steve calls proxy-based estimation. And the idea is you're basically assigning a small, medium, large, extra large value to a feature, but you can also use the same technique to specify what, let's say, the business value is for that feature, and then you can do a comparison between your business value and your development cost, and come up with a net value. So adding multi-language support to a website, maybe for this particular client, not very important, but the development cost pretty significant because the site's Drupal 7 and it's been running for a while and it's going to be a big lift, bless you. And so your net value there is -2. Probably not going to want to do that, or the client may not choose to do that. Whereas user profiles, super important for this client. It's not, I mean, it's a significant cost, but not as big, not that big. And the net value is a +1. So that's something that is likely, when you present that to a client, they are more likely to want to move forward on that. And they have a sense of what the overall size and scope of the project is. Okay, so schedule estimation. So that was the end of my talk on estimating the size of the project. This is how long it's going to take, and I have one slide on this and one slide on cost, and then I'm done. So you can see I really spent most of my talk on figuring out how big it is and how many hours it's going to take to do that. Because once you have that size and effort estimation, then you can more easily create a schedule estimation. In fact, he gives the industry standard calculation, which is that the schedule in months is 3 times the cube root of staff months. And I had to run through this myself to make sure I believed it. So I took a project that we did, and I looked at the estimate that we had, which was 300 hours of development. I was going to take and ended up going through that calculation. It's going to take about 4 months. On the left, you can see a visualization from a Git tool that showed the number of commits per month. And basically, we ran about 4 months and about 800 commits, or I think this is the number of commits that include merge commits. So I think that this is actually a pretty good sense. Now, obviously, you can compress schedules by adding more people, or by making them work harder, or by feeding them more sugar. But I think as a baseline, that's actually a pretty good value. Okay, so how much will that website cost? Well, that's easy. You just take the estimated number of hours and multiply it by that number of bitcoins. And all right. So, all joking aside, figuring out the cost of a website when you're doing business development, or and working with a client is a whole nother talk. And I didn't really think of that when I proposed this session. So stay tuned. I will do my best to come back next year with some type of follow-on to this that will include more information on how to estimate a cost of a project. Because I know not everyone here is necessarily interested in that particular aspect of it, but it's a fascinating topic because oftentimes projects are fixed bid, and you have a fixed bid project, and boy, if you get the numbers wrong, and how often are those numbers wrong? Yeah, right. How often have we lost money on a project because we did a fixed bid and, oh, look, it took 400% longer than we thought. So I'm really quite interested in this. We didn't have time today to get into that particular topic. All right, so that is the end of my presentation. I have 3 minutes for questions. Yes?
Just really quickly, I really like the estimation of both the business value and the effort.
The t-shirt sizing.
Yeah, but to do both of them, not just to do the effort one, because a lot of people will forget about that, measuring the business value. And another way that I've seen that phrase was estimating by the why divided by the how.
Oh, that's great. So the comment is about the value of estimating development cost and business value, and that another way that you've heard this said is, say that again?
The why divided by the how.
The why divided by the how. Okay. Right. That's good. That's a great equation. Yes.
So a lot of times teams change over time, so you end up with the team velocity, which is great, but teams fluctuate quite a bit actually. Especially if you have a mix of permanent and contractors or whatnot. Do you? I guess it seems logical to me that you'd want to measure the velocity per developer and then their accuracy. So you could always, every iteration, there's a new team, so we just take those groups of people, and add them all up, and then we have an actual estimated velocity. And X developer better at estimating than C developer, right? So has that something you've explored at all? Because it seems like teams change all the time, and it's not really easy to do this like as stated because they change all the time.
So the question is, how do you reflect the frequent changes in team membership into estimates? And I would say that's particularly in the agile front, where you're looking at a short iteration, 2, 3, 4 weeks, and trying to figure out what the velocity of the team is going to be in the next sprint. I think what you need to do is look at basically a multiplicative factor. So you basically say, yes, you want to figure out what this team's velocity is, but if there's going to be some modification to the team, then you have to decrease the expected productivity of that team by a certain amount. So maybe that's a 20% overhead for just team churn.
Okay.
So, and I think that's a little bit of specific to the teams that you're working with and your developers. The other thought I had there is that you can very accurately get a historical record of the amount of commits that a person can write, or the amount of lines of code that a person can write.
Commit velocity.
Commit velocity, I think, is actually a pretty interesting statistic to look at.
If it's consistent, I guess.
If it's consistent. So you can get a sense that teams and individuals may be more or less productive over time. Yes, I think 2 more questions. Yes?
So just a comment, or a question and a comment, I guess. Was there anything about the time it takes to estimate the estimate?
Well,
because oftentimes
yes.
It's okay, 5-10 minutes, and get back to me with what you think it's going to take, and it's like.
Yeah, I think for the expert judgment that you're decomposing a task and working on that, I would say it probably is 15 minutes, maybe 30 minutes for a complex task, to write down what the moving parts are. Maybe you're not going to get that list perfect, and there's no way you can get it perfect because you haven't built the feature yet. But just writing down the 10 things that are going into that and calculating a value for those, I can't imagine it's more than 30 minutes. However, the agile world has a beautiful concept of the spike, right? So you're going to create a spike sometimes where the spike is time boxed to 2 hours of research to come up with what it's going to take to build this functionality. So sometimes what you want to say is, my estimate is it's going to take 2 hours to come up with the estimate. That's my spike. And then I'm going to move forward with a much more reasoned and more likely accurate estimate after that. Okay, one more comment or question?
I have a metaphor.
All right, good. Yeah, back at the metaphor.
I always like to relate these technical things to houses because most people understand how they're built.
Yep.
So this could be similar to a very simple home improvement task where you built it or you know how it works really well. You have all the tools for it. And once everything's laid out and done and ready to go, it takes you a few seconds to do it. So like shaving the bottom off of a fence board or something.
Oh, yeah.
So you have the saws, you have the sawhorse, you have the extension cord, but they're all packed up somewhere. You've got to pull them all out, you got to pull the board off. Once it's out on the thing, you could knock out 1 inch, 2 inch, you could cut the thing into 20 pieces and it wouldn't really take much difference in time. Yeah. But the whole project, no matter what you're doing, will take you an hour.
Yeah. So the comment was back to our previous discussion of an analogy to describe the overhead for doing what appears to be a simple task, and clients will often think of it as a simple task. And the analogy is to a home improvement project or a construction project, home building project where, for example, if you're going to take an inch off the bottom of a fence, you've got to get your tools out, you've got to pull that fence apart. The actual cutting of the fence on a planer or table saw is probably, 1 minute of work, but everything else to get it taken apart, staged for the work, cleaned up, put back together is a good couple hours. All right, well, thank you very much. I think it's a great analogy. thank you for sticking around to the end of the conference for a fairly dry topic, and I hope it was